Okay, example 1, we're going to graph 2 periods of each function. Okay, and we're going to start with y equals 3 times the secant of x. All right, and so we're going to use the fact again that secant is the reciprocal of cosine. And we're actually going to start by graphing y equals 3 times the cosine of x. Okay, so everything is basically the same except the amplitude. Secant and cosecant don't have an amplitude, right? Because they go up forever and down forever. Okay, so they don't have an amplitude. Here, the amplitude, right, of this graph is 3. Okay, the period is the same. It's 2 pi over b. This hasn't changed. This is still a. This is b. Okay, period is 2 pi over b, so 2 pi over 1. So the period of this function is 2 pi. I'm going to graph it on the screen right here. Okay, our period is 2 pi. We don't have any phase shifts, right? It's not moving left or right, and we don't have any vertical translation. So that makes that easy. Okay, that makes our period 2 pi. So we're going to go from negative 2 pi to positive 2 pi. Finding our critical points the same way. Okay, we take our period and divide by 2, and that gives us the distance of our critical points. I'm starting at 0, okay, graphing the period that way, and then graphing the period to the left. Okay, cosine, we are going to graph cosine first, and cosine does have an amplitude of 3. Okay, we don't have a vertical translation. That means our midline is the x-axis. Okay, so when I graph cosine, right, I start at my max, midline, min, midline, max, okay, midline, min, midline, max. Okay, and so my cosine function looks like this. Okay, since secant is the reciprocal of cosine, that means anywhere cosine equals 0, I have an asymptote. Okay, anywhere that cosine equals 0, I have an asymptote. Okay, these points right here are the same. Okay, at negative 2 pi, cosine is 3. Okay, let me say that again. At negative 2 pi, cosine is actually 1, right? Okay. Sorry, the cosine of 2 pi is 1. And 3 times 1 is 3. Okay, if I take the reciprocal, okay, if the cosine of 2 pi is 1, secant is the reciprocal of that, and the reciprocal of 1, okay, is 1, so that means it's also 3. Okay, same thing down here. Same thing right here. Okay, and this is why we're using cosine to graph this function. Okay, and these go right up against those asymptotes. So that would be the graph of 3 cosine of x. Okay, if I look at where my asymptotes are here, okay, if we need to write our equation of our asymptotes, right, they're all vertical lines, they're all vertical asymptotes. I have an asymptote at negative 3 pi over 2. I have an asymptote at negative pi over 2. I have an asymptote at positive pi over 2 and at positive 3 pi over 2. So those are the equations of the vertical lines where I have asymptotes. Okay, the next function I'm going to graph is y equals the cosecant of 3x. Okay, since cosecant and sine are reciprocal functions, I'm actually going to graph sine of 3x first, and then cosecant from that function. Okay, so cosecant, just like secant, does not have an amplitude. Okay, but the amplitude of this function, which I need to know because I'm going to graph this first, is 1. Okay, period is going to be the same. Okay, it's 2 pi over b is 3. Okay, so my period is 2 pi over 3. I do not have a phase shift, which makes that really nice. Okay, I don't have a vertical translation either. So when I graph this function, I'm going to go from negative 2 pi over 3 to positive 2 pi over 3. Okay, let's talk critical points here. If my period is 2 pi over 3, that means that the distance, right, between critical points is 2 pi over 3 divided by 4. Okay, so that would be 2 pi over 3 times 1/4, which is 2 pi over 12, which is pi over 6. Okay, so the distance between each of my critical points is going to be pi over 6. That means if this critical point is 0, I would add pi over 6 to get this point. Okay, and to get my next critical point, I would do pi over 6 plus pi over 6, which is 2 pi over 6, which is pi over 3. Okay, pi over 3 plus pi over 6. I need common denominators here, and actually I already know that's 2 pi over 6. Okay, so that's going to be 3 pi over 6, which is going to reduce to pi over 2. Okay, and I should, verify this. Pi over 2 plus pi over 6. Okay, pi over 2 I already know is 3 pi over 6. That is 4 pi over 6, which reduces to 2 pi over 3. Okay, which is what it should be. So that works out great. Okay, I would do the same thing to get my critical points going this way. I would start with 0 minus pi over 6, which is just negative pi over 6. Negative pi over 6 minus pi over 6 is going to be negative pi over 3. Negative pi over 3 minus pi over 6 is going to be negative pi over 2. All right, so I'm starting by graphing this function. It has an amplitude of 1. So I start at 0, I go up to my max, midline, min, midline, same thing in the negative direction, min, midline, max. Okay, and so it looks like that. Okay, remember that cosecant is the reciprocal. So everywhere sine equals 0, cosecant is 1 over 0. And 1 over 0 is undefined because you can't divide by 0. So everywhere sine equals 0, I have an asymptote. Okay, and then I just fill in my graph. And it looks like